last part of project 2, so I call it project 2, part 3. There's 3 parts to this one. In D2L, there's the typical Word document, and then there's a compressed file that you can download. Actually, I'll just do it. So, download that compressed file, listen to my downloads folder. I know you can't see me. So I go to my folders here, go to download, it looks like that, it's a compressed file. And on these machines, just to extract all, I don't, we did this before, I'm just gonna do it in the same place. And you extract, and it makes a folder, right where I got that zip file, my downloads, but it's got a folder with 9 parts in it. Should be 9 parts in it. Sometimes it is a folder inside a folder, I don't know why it does that. So on the OCC machine, you just right click and extract. I know on your laptop, you might have a different method of unzipping or uncompressing files. I know they have 7-zip as the software that does that. And usually if you right click on it, you'll see what choices there are to extract or unzip things. But there's 9 files. Those are all going to be added as the rest of the assembly or the entire assembly. We really haven't done much with the assembly yet. But we're going to assemble the parts. That's what this exercise is. Put all the parts together, line them all up correctly, constrain them correctly. The 9 parts are included here, and some of them we're using multiple times. Like there's 4 of those socket head cap screws. It says times 4. You're going to use 4 of them. It says times 5 by the tool holder, but that's not the number. That's the times 5 inches. But there's a couple of shims. There's a shim, we're going to use it 4 times. There's another type of a screw, we're going to use it 4 times, and so on. There's more than 9 components in the assembly because we designed 2 of them ourselves, right? The 2001 and the 2002 models. That's the block in the cap at the end cap or top cap. So I didn't provide those to you. You made those. And then there is the tool holder itself, the screen thing, and the insert. I gave you those in an earlier exercise. So there's really 13 parts altogether. 9 you're going to get today, and the other 4 either you made them or I gave them to you earlier. Okay. And they are. I do want them all to be constrained correctly so they're lined up. And I have constraints. I don't have them visible on the screen, but I do have a list of constraints at the top of the assembly. There's quite a few of them there. All those green check marks are different constraints. Okay. And if you do show them, they're all there. As I'm doing my demo, I'm not going to go through every constraint in every part, and every insert, and every add component. Most of that we've done a few times already, so I don't need to spend all my time just talking about that. I'll just highlight some things. There are a couple of things that we didn't really do, and I didn't really demonstrate before. With respect to constraints, just a little bit. And then we're going to make a drawing, an assembly drawing. I also have that shown here. It's going to look like this. It's an assembly drawing only. Yeah, you're going to put a parts list on there. You're going to have the little balloons. What we haven't really talked about in my class here, and I don't know if we even talked about it in any of the next classes, but we're going to make a section view. So I want to just take a little time to talk about that one. And a detail view like this. Okay, we may not have done that. You may not have done that. In drafting stuff in NX might be kind of new to you still. I know we did a lot of it in our CATIA classes, but not necessarily in NX classes. So there's a couple things I just want to talk about. So as far as the assembly here, okay, and I'm just going to look at my document just to make sure I'm not missing something. You know, the Word document. Typical one, show you a picture of the assembly. I show you a picture of what the drawing is going to look like at the end. This is just a quick snapshot of it, but you get all the details. And then it tells you, go ahead and download that zip file and unzip it, and then you have the 9 parts. Then you first bring together the first couple of parts. Maybe I'll hide the constraints again for right now. I like to do this. I'm going to hide all these just to help my demo a little bit. first thing you do is have those two parts, and depending on how you design them, I don't remember if I told you exactly where to design the part with respect to their origin. You know, if I show the entire part here. So this block, I designed it so that back corner was at 0, 0, 0. And the cap on the top, that one I designed it so it's absolute 0 was right there. So if you bring them both together in an assembly, then their absolutes are sitting right on top of each other, so this green one would be sitting down here, kind of right in the middle of the room. So obviously you have to do a constraint that lines up the cap on top of the block, right? So again, I'm not gonna rehash all that. But you can do touch a line in between, and then you can line up. You only have to line up 2 of the 4 holes, because once, if the bottom of this and the top of that are touching, they can still slide in any direction. If you line up one of the holes, it can still rotate around that hole. And then if you line up one more hole, then they're completely locked. As a reminder, if you go to assemblies, remember there is this guy in the more button, it says show degrees of freedom. And if you click on a part, the first glance you go, well, it doesn't show anything. If you look at the message on the bottom, it says there are no degrees of freedom. So that means that part is fully locked. How is it fully locked? Well, because it's completely tied to this one, and that one I did fix it. There's a fixed constraint on that guy too, right? So just remember that. Another thing you can always do, a little trick, you turn on assembly constraints, and as long as you don't have like the fix selected here, if you have it on one of these guys like touch the line, you can drag things that are still free to move. It won't let me drag it because it's fully locked. So anyway, so I have you first put those in there, then it does say to add the key down here, and I just put a little note in there, because it's another thing, again, I'm just highlighting some things about constraints, some of the constraints. You can kind of tell by looking at this, the top of this key, the surface on the top, it should be touching the surface on the bottom of this, where that notch is, right? Well, those two surfaces are touching, so it would do a touch. Same thing with either this wall in the corresponding wall in there, or this wall in the corresponding wall. Or one or the other, you don't have to do both. But those are touching, right? The top of this wall is actually touching the inside of that one. But the last thing, just with those lined up, this thing could still slide back and forth in the X direction. So we do one more constraint, where we take this face and line it with this face, but they're not physically touching. I mean, the edges of it, the faces aren't physically touching. And so I mentioned in a note there, it says, even though we use the touch and it said prefer touch, it's gonna make that one in a line. It does that if the faces aren't physically touching, and sometimes it'll do it if things aren't exactly parallel too. But it makes it a line. Just in case you look at the list and you see, okay, I did that's the key stock, I did a touch, then I did a touch, and then I did what I thought was another touch, but it made it in a line. That's because the outside face there and the outside face there are not physically touching each other, all right? Something to know. Then it says, put the 4 socket head cap screws in there. And I have a little note there, I have a hint that says use scatter in the add component window. Why did I say that? Because I didn't explain why I said it. You don't have to do it, but here's what I meant by that. If I go to add component, and I want to grab that socket head cap screw, and I want to bring in 4 of them at once, you can do that, right? 4 at once. Okay. There is, what I was talking about, under settings, there's a scatter components button. If you don't have that on, and you bring in multiple copies, multiple instances of the part at the same time, you hit OK, there's 4 of them that came in, but they are all on top of each other. It's not the end of the world, but it just makes it harder to grab them individually. Not that, my next step would be, okay, take this first one, line it up with maybe that hole back there. Then there'll be another one here. Take the second one, line it up with that hole. You can do that. Or, like I said, as a hint, if you just turn on scatter components, all that does is when it brings them all in, you see how they're already visually, you can see they're scattered. That's all it is. It's just so they're not on top of each other when they first come in. It's just handy. You don't have to do it. Another thing, since I did this, I see a bunch of planes on each screw I brought in, okay? The reason that happened is because when mine came in, remember there's filters on your parts when you're in an assembly. And the normal filter is called the model filter, and that only shows the bodies, solid bodies and sheet bodies. But when you see planes, that means you're not looking at just the model filter. Well, if I look at the screws right here, remember they're filters, but they're called reference sets. If I go to replace reference set, probably because some of them were and some of them weren't, the ones I had before. Well, it was on the entire part, that's why you see the planes. If you set it a model, you don't see the planes. Okay. And not to go too deep into this, but since I'm on a roll here, I'm actually gonna undo that to the early details, because I already had my socket head cap screws right there. But when you add components, we know now because I just showed you. Once it's already in the assembly, you can right click on anything and change the reference set. Okay, it'll show like a CSIS or a sketch or whatever else is in the part, right? But you can also decide, you can also decide what reference set it's going to show as you're bringing it in to the assembly. So if I go back to add component, there's another setting on here. I just showed you scatter components. Well, way at the bottom of the list, way down here, actually you have to pick a part first. I'll just pick something. At the very bottom of the list, it says reference set. So as you're bringing in parts, and usually you only have to change this one time. Mine was set the entire part for some reason. My add component command. So that means when I add components, they all have a reference set. They all have filters. It was going to put them all on the entire part. If I change it to model, then any parts I bring in, as long as it still says model, it's going to use the model filter right off the bat. Okay. Just again, it's nothing to do with tool and die, nothing to do with this assembly, but it's good to know. Right? Then I talk about having you. Let me hide this guy. Hide this for now. I talk about bringing in the tool holder, and all I'm really telling you is it fits into this channel. And again, I want to line everything and lock it all down. So when I'm trying to tell you with the pictures, it's kind of hard to show you pictures like that. So I said, make sure the side faces of the tool holder is flush with this wall. We got to look at that arrow pretty close to know which wall I'm talking about. What I mean is, this wall on the tool holder, I want it flush with this wall of that channel. The bottom wall of the tool holder, I want it flush with the bottom wall of the channel. So it's kind of tucked over on the side like that. So in this view, it's kind of shoved in the bottom left corner. This guy is in the bottom left corner of this channel, right? Now that's not the only constraints I want though, because just with those two constraints, this thing would be able to slide back and forth still. So what I have you do, and this is something that, in the tool and die world, we're talking about this in the NX world, but in the tool and die world, how far do you want that to be able to adjust? And how far do you want it? Well, I have you do that by putting a distance dimension in there, 3/4 of an inch or 19 millimeters, 19.05 millimeters, right? So there's that, okay? And then you bring in the the handle, like so. And I just wanted to bring something up here. So you can see, it tells you, line up there's a hole, there was already a hole there that we made earlier when we designed the block. You want the shaft of the screw, of the handle, or the threads of the handle, that shaft to be going down the middle of the hole. How far do you want it to go? Well, since we've already established that this is 3/4 of an inch, our only task is to make sure the end of the screw here, that shaft, is flush with the end of that guy. And I just want to say this. In this case, it works out pretty good, because this screw, if I had that roll, the end face of that screw is flat. That's a flat planar face. And it's exactly perpendicular to the center line of this, okay? That's kind of important. The fact that the end of that is flat and perpendicular to the center of that. Because if that end was flat, but it wasn't exactly perpendicular to the center line of this, it wouldn't let us do a touch a line between this wall and the end of the screw. Because we already have the handle, the screw of the handle, exactly down the center of that hole, okay? We already have this face where it is. If that end face, after doing those two things, if that end face of the screw was not parallel to that, it wouldn't let you do a face to a face. It would say you can't because it's got a tilt. You'd have to do it some other way. Just so you know, you can do a touch a line. You can actually do an edge. Sometimes there's little edges there you could pick and make an edge of this screw. In this case, you don't have to, but you could have made this edge of the screw right there flush with that face. It'll let you do that. Or, another thing that's actually commonly done, I don't have you do it in any of these assignments, I don't think. But you could have created a plane in the handle file, or there could have been a plane there, right at the end of the part. And there could have been a plane on the end of the tool holder, right at the end of it. You could do assembly constraints by picking planes, instead of picking planar faces, right? Like instead of picking the back face of this, if there was a plane in that part and I could see it, you could select that. A lot of times you do that when the parts themselves don't have perpendicular or parallel faces, so you can't really line them up just by picking a face. A lot of times that means in the part, you'll go into the part individually, create a plane right where you need it to be with relation to some other part, and then constrain the planes. Now, how do you show the planes? Well, that's what we were talking about before. You would have a plane there, and you have a reference set. You might have to show the entire part. And if there was planes in it, I would see those. And then you pick. Okay. So again, I'm just going on about these things just because I like to hear myself talk. But it's important stuff to talk about too, right? It's good to know those things. And then you're going to line that up. It gives you some hints about lining that up. Basically, I want that nut to be flush with that wall, but I also want it centered on the shaft of the handle there. Okay. Then you put a couple of shims in. There's only one shim file that I gave you, but you just bring two copies of it in. And this one too, it seems pretty obvious, but not necessarily. The shims have to, I want them not to be able to move anywhere. So the bottom of this shim is touching the top of that tool holder. The outer edge of the shim is touching the inside of that channel wall there. I also still have to stop it from sliding back and forth. So the front face of this shim is going to be flush with the front face of that block. Same thing for that one, okay? And again, you know what when I pull up your assemblies, I'm gonna try moving stuff around, see what happens. So if I go to if I go to assembly components and I try to drag someone, if it lets me drag it, then it can still move. Those shouldn't be able to move. Now, that being said, there's a couple things I was gonna say. If I go to the handle, I can still move that. I'm considering my assembly done and fully constrained, but I can still move that, right? Or I can move that. But that's okay. That's not changing my assembly, right? I mean, in real life, that's gonna move. And in this case, it doesn't matter. You know, is that face supposed to be parallel to the top? There might be instances where it is. In this case, it's not. You know, when you tighten this, do you care if it's like that or like that? Most of the time, no. But if you did care, that is still a degree of freedom that you might have to lock down. Well, all I would do is say, well, let's take that face and make it parallel to that, and then it will lock it down. Right? So just an FYI. Fully constrained assemblies, as far as functionally being fully constrained, that doesn't mean every part is really fully constrained. And one more thing. If I go to show degrees of freedom and I pick the handle, see that thing pops up? That's telling you that handle can still rotate in that direction. I haven't talked about this before, but I like to remind you. Okay. You can just continue working, that thing will disappear eventually, or you can say refresh the screen and it'll go away. Right? So anyway, we line up that. Oh, the other thing I was going to say then. After lining this up, you know, we did talk about earlier how remember how we had to come up with where this hole was for the handle? And what we really did, we lined it up such that if the tool holder was right there, we wanted this to be in the center of the back face of the tool holder, right? But that might be something in the tool and die world, you might rethink that a little bit. Because, well, yeah, that's where that size of tool holder, it was 3/4 inch by 3/4 inch. if we put it flush against that side, then the middle of it is right there. But what if we design this tool holder assembly, and we know that maybe we're gonna use another tool holder besides that one, and maybe it's not exactly 0.75 by 0.75, maybe it's not 3/4 inch by 3/4 inch, maybe it's smaller, right? Well, if this tool holder was smaller, then, and we still want it to be flush against the walls, then the end of it wouldn't be here, it might be over here, right, coming down here. Well, if we still want this to be in the center of it, well, that's in the wrong spot. So you gotta think about that stuff too. We were assuming the whole time we were always gonna use that size of tool. But in the real world, you might have to think about things like that. Well, what if we use different sizes? Is that the best place to put the hole? In the center of that one, or should we maybe move it over a little bit so it can accommodate other sizes? So stuff like that you gotta think about, right? Let's see, we got the shims. Well, then we got 4 of those guys, and I essentially just show you a picture here. Line up 2 of them with the holes on the top and 2 of them with the holes on the side. But then you have to also constrain them, and normally this guy's showing so you don't see it, but I try to show you in a picture. Yeah, we know how to do center line to center line. The whole center line with the screw center line, that hole and that screw, right? But we also want it flush with the shim. It's kind of the same thing as the handle. Luckily, these screws come with a flat face on the end that is perpendicular to the center line, so it works out great. It may not always be that way, but in this case, you can make the end face of this flush with the top face of that shim, same thing with the ones on the side, and it works out perfect. Now, when you do bring in those 4 copies of that thing, that screw, it's M10, SSS, whatever it is, okay? I do tell you, bring those in and line them up with the holes, but I also tell you, make sure the hexagonal recess, the hex head recess is on the top or on the outsides. And what I mean by that is, those screws, see how they have the hex head there? Well, the other side's flat. You want to make sure when you bring them in, because sometimes when you bring them in, you say, all right, line up the center lines. Sometimes it puts them upside down. The hex head's on the bottom and the flat side's on the top. So be aware of that as you're making constraints. When you first bring them in, zoom in before you hit OK. Zoom in and make sure the top has that hex head on it like so. Okay. And also, I tell you, when you do have it lined up correctly in there, they should be a little bit recessed like you see there. Same thing on the sides. Okay. And those two, by the way, if I go to assembly constraints and I zoom in over here, that guy is actually not fully constrained. He's still free to spin like that, but that's something I don't care. It's not, it's not really using threads. It's not moving it in as I screw that in. It's just staying exactly the same spot. But, so, there's that concept, okay? And then the little bit trickier part, you're bringing in the insert. And at this point, now I pretty much graded a lot of the last exercise where you put that recess there, that pocket, and you put a hole there. And I didn't really look at it really close to see if you got them lined up exactly right. But you'll find out when you're doing this exercise if you got them lined up right. Okay. Because remember you had a CSIS, you put a CSIS up here where we thought the hole should be in the center of that triangular insert, right? Well, if you go to add the insert and you didn't quite make that recess exactly the right size or shape, you'll find out here because it won't fit in there. Right? And you have to make sure the hole's lined up like so. Now, to fit this insert into that opening, there's not just one way to do it. The way I did it was I did a touch a line between this face on the insert, this outside face, and the corresponding face in the pocket here. Then I did the bottom face of the insert with the top face inside that pocket, which still allowed it to slide this way and this way. So to stop it, to completely lock it, I also did the center line to center line. The center line of this hole and the center line of that hole. And if you didn't make the recess and the hole in exactly the right spot, it won't let you do that. It'll say, well, if you got this wall lined up and that wall lined up, then you can't line up if the angle of these walls weren't correct or whatever, it wouldn't let you do the center line. Okay. So that's another thing. And then you're going to add the flat head screw And one thing is pretty obvious, yeah, the center line of the screw goes through the center line of the hole, but it's also supposed to be flush with the top of the insert. By that I meant this face is flush with that face right there, right? Which could be a touch of line. We call it a line because they're not physically touching because we're going up. Okay? And then the other big thing is you bring in this guy, okay? That's when you find out, did you really make the counter bore hole the right depth? Because the bottom of this, there's a shaft on this guy. And the bottom of that shaft has to sit on that bottom flat of the counter bore area. Remember that counter bore hole has the actual threading, or the hole size there, and then there's the counter bore above it. So the bottom of the shaft should be sitting flush in there. If it's sitting flush in there, we hope it is, because then that means where this little contact point is on the bottom, it should be touching the bottom of that little recess in the insert. That's only going to work if we made the depth of the counter bore hole correct. It's also only going to work if we made the distance to the center of the counter bore hole correct. Remember we talked about that in the previous exercise? Because I wanted it to sit kind of like where it is right there. I didn't want it too close to the edge here. I didn't want it too far that way. So I wanted to make sure that the center of this shaft part of the claw was at the right relative spot so that the end of the claw was right there. Okay? So you'll find out if you did the right numbers when you add this guy and try to constrain it. Okay? And the same thing, there's the screw there, right? That, you know, as long as you line up the center lines, and to stop it from moving up and down, the underside of the screw head should fit flush with, there's a little face inside there, okay? But there is a constraint here that we just didn't use very much, so that's, again, I wanted to highlight just a couple of things. If I show all my constraints, there's an angle constraint here. This isn't the only way you could have done this, because when you first put this in the hole, it can spin around freely, right? But I have an angle constraint. And in this case, it worked out pretty easily because that's a flat surface right there. I think I talked about this last week. That's a flat surface. And it just so happens that should be perpendicular. It's flat, and it's also described as the two sides, they're both flat on this side and that side, and they are perpendicular to the main direction of this, which means that's good, because if that's perpendicular to the main direction of this claw is coming down this way, and it can be normal to that edge. So you're making an angle constraint right there between that planar face and that little edge, and they're 90 degrees to each other. Okay? If I change it, angles and distances, they come with numbers. You can double click on an angle and change it. If I make it something like 80, see how the part rotated? It's not lined up like I want it to be. So if it's 90, it should fit right there. Okay? And even looking at that, I don't know, I'm going to say that's good, but it could actually be looking at that. It could be that hole could have been moved a little bit to the right in this orientation. That would have, see how this isn't exactly centered right there? I'm going to say it's okay, but in the real world, you might rethink that. You might move that over. I'd have to change the position of that hole. That hole's position was this hole, the counter hole. That was all based on the point. There was a sketch. Going back to Osesis over here. But that's fine the way it is. And I like to show this as a reminder of something also. So I mean that's the entire assembly, all constrained. But remember this neat little tool. If you want to look at that, because I can look at this all day and try to look underneath it and rotate. Is that touching on the bottom? I can't tell, because when I try to rotate, everything gets in the way. But I'll remind you of this. This is not in my instructions, so if you want to watch for a second, this is a handy thing to know when we work with assemblies. If you go to View, and there's this guy right here called Edit Section. It's in the content. I don't know what content means, but it's called Edit Section. It does it's a section tool, just visual. It lets you see right in the middle of the part, or in the middle of the assembly, okay? Now, it throws this manipulation tool right in the middle. You can move it, change your section. You can rotate it, changing your section, right? You can also say, well, absolute Z is the cutting plane of this, basically the XY plane, is perpendicular to Z. You can say make it perpendicular to Y. No, that's not what I want to do. How about perpendicular to X? That comes closer, because what I'm trying to look at is, I'm trying to look at this up here, where they meet, and actually that's almost good enough right there, but that's really ugly. It's hard to see anything, it's real bright. Probably looks great on the screen, right? If you want to use this tool, I mean, it's very intuitive. If you go to that tool called Edit Section, or View, Edit Section, this pops up, and just start going through these settings and you can figure stuff out real easy. One thing is, the cap, that yellow, ugly yellow color is the cap. It's like everything's blended together, I can't see it. You go to cap settings, you can say instead of making it a specific color, let's use the body color, so each part has its own color then, okay? Makes it a little bit better. But then you can also say there's section curves, like around the edges. You can say, let me show the section curves. Usually by default they're blue, which that might be fine. You can also say, use the body color of each one. That's not bad either. Okay? So I'm just giving you a little bit of information about something that might be kind of fun to use. It might be disappear. It actually makes something in the tree if you create it. When you edit it, I don't want it to disappear. I didn't really want to keep it. I just use this temporarily. Usually I'll bring this up, view things, move it around, and then cancel it. It will save it if you do okay. But what I want to do is look at it. Yeah, that kind of helps. I mean, I can tell what I really wanted to know right there. See how you can see that? Yeah, it doesn't look like it's going through it. It looks like it's stopping right there. I can line it up even better. I can do this. I can say display settings. You're not going to remember all this, but I can say move the manipulator into view. So there's the manipulator. I could say rotate a little bit more and drag it out this way so it's more true to that edge right there. I don't know why there it is. So you know what I mean? You can manipulate it so you're looking at just the right angle you want. I know I'm not really teaching this. I'm just telling you basically, hey, for your own good, play around with this guy called Edit Section. It's really handy if you want to look at what's going on inside of things, right? So anyway, that's kind of telling me, you know what, I think I picked the right depth. And the fact that that's touching right there, and there's no space between them, but it's also not penetrating inside. What that really means is the carnivore depth right there is exactly the right depth. So that's what we talked about in the previous exercise. Okay. So there's that guy. Now, I actually did save it. It puts it up at the top of the tree. It's a section. I want to delete it. Go back to that. All right. So that's a big part of this, right? Lining everything up. Then you're going to make the drawing. So, you know, it's the same old thing. I don't give you this drawing, this template. I gave it to you back 2 or 3 assignments ago, the template assembly drawing. Basically says open it and do a file save and name it to 2001 or 2000 DWG01, right? I won't do that, but I did it before. Actually, I did it in my earlier one. That's the finished one, but I just want to show you a couple things that we hadn't talked about before. You already know about the parts list and whatnot, but let me make a quick base view. Oh, I'm sorry, I forgot something, right? This drawing is just kind of sitting here on its own, it's not pointing to anything. If a drawing is supposed to represent a part or an assembly, well, you need to hang that part or assembly as a child of the drawing. So I got the drawing open, there is an assemblies tab. I can go to add component, and I can go to loaded parts, and I got my assembly right there. And I want to make sure I don't want 4 copies of it though. Actually, it's good having it. Remember to hit reset, and then say, let me go to loaded parts and make the assembly, and make sure you're on absolute. So now I have the entire assembly as a child of my drawing, so that if I now go to base view, it's base view of my drawing. Okay. And well, it also says, hey, make sure you go in there and rename that stuff in the title block, like you've done a few times now. It does say make your first view as a front view. That means here, make it, use the front view, the NX front view as a front view of this. Yes, you're gonna go into all the settings. You're gonna show center lines. You're gonna have hidden lines as dashed lines. I won't worry about it right now, but that one, actually, I'm not looking at the hidden lines, but you will, yours will, okay? And then you're gonna make one top view like this, okay? Then you're gonna close that, because remember when you make the front, the base view, always automatically, once you're done, it automatically goes to projected view. In this case, we only need one more projected view. I'm gonna have a side view, but we don't need to have both a side view and a section side view. So if we do the section side view, that's good enough. You'll see what I mean when I do it, right? So anyway, we're gonna do that. You're gonna make an ISO view over here. But because we haven't really done a lot of this, I don't know if I even talked about this at all in any of my next classes. You know, this is a piece of paper, we're gonna plot that out, right? And if you're standing and looking at it, you wanna get a little bit more detail about this area. Well, that's pretty small, you gotta zoom in a lot. And I'm in CAD here, I'm zooming in. If it's a printed piece of paper, that means I gotta put my face real close to it. Maybe use a magnifying glass or something, right? Well, because I wanna call it out, maybe dimension it, I wanna make a detail view. That's what a detail view is, all right? Here's detail view. And I'm just showing you the basics of it. I'm gonna hit reset to make sure it's on the defaults. Usually they are circular. It's basically saying, let me zoom in here. Let's take a picture of that close up and put the picture over here, bigger, okay? By default, it's a circle. The type down here, it says, the label type says note, but we actually want to use a label type called label. You'll see what I mean when I do it. And I guess I gotta pick the location first. So it says specify center point. I'm gonna draw a circle, right? What do I want to zoom in on? And I'm trying to tell you in the instructions, kind of hard to tell you, but there it says click here for the center point in one picture. What I kind of mean is right about here, click right about there, start moving your cursor, it makes a circle. All we really care about is I want to show the claw and the insert, so make sure the circle's big enough to capture the insert. And then you make this, I'm not going to make my second trick yet. Now that I've started, I want this to be 4 times the size. You can always adjust it later, but I tell you to make it 4 times the size. Then, we're just eyeballing it. Just make sure it's big enough to get the insert in there. Click again, okay? And even at this point, you can change it to 4 if you didn't yet. And you can see there's my zoomed in picture. Where do you want to put it? So where does it look good on the drawing? Put it right there, and I placed it, and that's a detail view. You could make detail views rectangular or circular. Most of the ones I've ever seen are circular like that. The label, we picked a type called label. That means it's going to show the letter and an arrow pointing at the circle here. The call out over here is detail A. So that A references that A. Okay. So that was something we really didn't spend time talking about before. And then the last thing I'll talk about is the section view. Okay, we do, I do need to see a side view of my assembly if I truly want to see everything. The top view doesn't show me everything, the front view doesn't show me everything. I would probably want to see a side view also that shows me those 3 together is almost everything I need. So here's section view. Okay. Now I could spend an hour talking about section view. I'm just giving you the typical way you use it. It's kind of neat because the typical way you use it is the way you almost always do use it. Because it's the typical, right? And it's very handy, I should have said that. It's handy. So I just make sure I'll reset. The dynamic type is the default. There's another one called select existing, which you'd have to create. You would have to use this guy up here to create a section line first, and then use that one. That's kind of like using Sketchbook. But anyway, I'm going to do a default type, simple step, whatever that means. The hinge line is inferred. Okay. What a section view is you have a reference view, starting view, parent view they call it. And I want to say, what if I cut my part down, right down the center of it this way, and then flip it out sideways so I'm looking at it from the side. So I cut the part in half right here, and I'm standing here looking at it. That's what I wanna show over here, okay? Well, that's what section view does. The easiest way to use it, and the normal way to use it, is you just draw a line through your part where you wanna slice it in half, okay? It is a straight line by default. And if I want it exactly in the middle of this way, right, well, in this direction, I want it exactly in the middle. So I'm gonna cut through the part this way, I want that slice to be in the middle of the part. There's different ways we could do it, sometimes it's not so easy. This part would be easy because there is a midpoint, that edge right there is a midpoint right there. That little point, I know that's right in the middle of my part. If it wasn't, you could pick points. You could say, let me pick a point on an edge or whatever, you could pick points. I could pick anywhere if I wanted to. But that makes it really easy to pick the center. So I'm gonna pick that, okay? I picked it. What that did was it took that, they call it the view and direction arrows, or the center line, the section center line. It put it through that point, so this dashed line is always gonna go through that middle point, which is right here. As I move this around, see how wherever I move this, it's still going through that middle point down the bottom. Right? Well, that's kind of funky when I start doing this. Why would you want that? Well, I don't. But if I go all the way to the side, see how that's what I meant. It's right down the center of my part, cutting through it the way I wanted it to, right? Now there's arrows there, those are called view and direction arrows. If I move my cursor on this side, that means if I'm standing on this side, I'm looking at the part, the same direction those arrows are. I'm viewing it in that direction. If I'm standing on this side of the part, the arrows will go the other way, I'm viewing it from that direction. That's called view and direction arrow, right? And it's actually, that rectangle is the outline of the new view I'm about to create, right? So it's going to be it's overbuilt a little bit, it'll be roughly the size of the view that's going to make. I was going to make something else before I did that. Oh, just FYI, that's a typical way to use it, like I said. What's really cool about it is that all you have to do is kind of tell it where the center of it is and what direction you want it to be, but you don't have to give it the length of that line because it's smart enough to know it's big enough to cut the whole section of the view, whatever view you're in. See how it's taller right now, that section line? Because I'm looking at it the long way. If I come down here, see how that arrow, that section line got smaller? It says, well, it's just as wide as the view. So the view this way is a little bit taller. It makes it wide enough. That's why it's really handy. You could, here's what I was going to say. If you ever want to experiment with section views and do more than that, excuse me, you can go to where it says section line segments. You can actually pick other points and put little jogs in there. If you want to make some kind of weird section like that, it's not a straight slice through it, it's a slice that does all kinds of things, right? Of course, you don't usually want that. I'm just saying that's what you can do with section view. I'm going to do it the easy way. That's very handy because that's right in the middle of my part. I'm going to click on that. I want my section over here to look as if I'm standing on this side looking at it. I'll put it right about there, and then you place it. There's the section. Okay. Now, again, we could talk about that a lot more. We could spend a lot more time on it. There's a lot of different ways to do a section view. And keep this in mind, and even this is a question. I went through the middle of the block, really. The block is this width, or the cap is that width. I went through the center of it. Remember that the tool holder itself is not centered in that hole. These screws here that we put up against the shims, that one is centered, but the handle in the back, that's not in the center of the part. It's shifted a little bit that way. So when I look at this section, I can say that yes, it is exactly down the middle of that screw and exactly down the middle of that screw, but that's not exactly down the middle of the handle shaft or the middle of that nut, because those weren't at the center. Make sense? Just something to be aware of. I can make another section through the middle of that handle if I wanted to, or through the middle of the cutting tool. You can make as many sections as you want. It automatically does a call out there too. It's the letter B, because my first detail was an A. The system by default makes the next thing a B, and it calls it out here. That section B, that's the B, right? So there you have it. All right. And then you're going to do what we did before. You're going to do a parts list. Parts list. Remember that you have to come over here, you gotta say, I wanna select objects. I wanna turn off the assembly itself and just pick that, maybe hold down shift and pick those. Hold down control, sorry. That and that, right, you gotta pick the ones you want. You wanna turn on balloons, show balloons. And then, I missed something. Oh. Alright. I don't know why it's not letting me. Oh, select view, I forgot to select view. I want this to be in the section view. Okay. Then, as I'm moving this around, I go back up to specify location and stuff like that. And it tells you all this. I'm kind of wasting your time by talking about it, but I like to talk. So it tells you this in the instructions, but we want to place this so it's sitting, flush on top of the title block, right? But it's at the upper left corner. You right click, you go to the settings. You can go to common section and say, I want to do it at the lower right corner. And then you can pick the end of that little line, put it right there. And remember, I placed it, I can make these longer, and whatever it takes. And in reality, you'd spend a lot of time doing this part of it to make it just right. And in fact, I don't even have you, this text is not quite the same text you're using in the rest of this drawing. I could get picky and I could say, you can go to the settings, change the font, change the size. It's good enough just to use this one, but I'm just saying that in real life, you're gonna be a little bit more picky about the drawings, and the parts lists. And then it pops all these out here. I tell you that, okay, it's gonna put them out there, but I want you to line them up differently like it shows in these pictures right here, okay? Just to make them more aesthetically correct, or looking better. Because where the system puts them, they're all kind of right next to each other. It's kind of hard to tell. What is that pointing at? What's that pointing at, right? So I'll just do one to remind you, or maybe two, to remind you. If you click on or if you double click on that guy, remember there's a little point right there. Actually, though, it says select terminating object. You can just put your cursor right there. If it's not letting you pick an edge, a point on an edge, you go in here and turn on point on curve, it goes off. But if I say, well, I really wanted to call it out right there, it moves right there, right? Because I think, well, that's a better way to show them it's pointing at that. Because you might think, was it pointing at that center line, or was it pointing at the screw? Well, I moved that one, because I thought it looks better. So that's how you can move them. You can also go even further than that. You could say, because, well, this stuff is kind of small here, and since I went through all the trouble of making this really big up here, why don't I take, what's number 5? Number 5 is the insert, okay? So I can double click on number 5, select terminating object. You can go to a different view and pick something like that. Okay, and then number 5, over here, so I have you do those things. And so that's enough. I mean, we did that before, that's enough for me to talk about it. One other thing, and I've noticed that, it happens to be quite often, it happened when I was making my instructions. Sometimes it's got something missing, right? This case actually looks like you got them all. I think there was 13 things, looks like you got them all. One of the last times I did it, it was missing one, only 12, right? Or no, I'm sorry, it got them all, but there might not have all been on here. Look. Yeah, I don't see a number 4. I don't know why that happens sometimes. So what's number 4? Number 4 is that flathead screw. So I don't have a call out for my flathead screw. I got the pan head screw and I got the claw. But there was a little screw there, and I don't have it. And I don't know why that is. I can't tell you why. But I even mentioned this in the instructions. It says, if any balloon call-outs were not automatically created, there's a balloon command right there. Go to the balloon command. I do want mine to be for this screw. Okay? So if I go to the edge of that screw, and I say, let me pick the edge, turn off the center, and just start dragging it, I'm making a balloon, you go, that's not a balloon, that's a triangle. Well, I could make it a circle. And in there, I could type in a 4, because that's the one that was missing. And then I made my own. Oh, you can put a stub in there too. Okay. So I don't know, I don't know why it does in this one. The last couple times I've done this assembly, making balloons, it missed one of them. Missed number 4 in my case. Okay? All right. So when it's done, you will have this assembly. There'll be a file that's an assembly. I'm sorry, the file that's the drawing of the assembly. There will be the assembly file, and there will be 13 parts. 15, so that's 15 files that you will put in the D2L submission folder. Am I being logical? Okay? Hopefully you learn something new if I talk that long. If everything I did was like, we already did that, and I just wasted your time. Almost never replaced. Okay. Have that in.
Thanks, Dave.
Thank you. Last couple of days, I'm really putting in my grading, so a lot of the grading.
Yeah, I got told, thank you.
Yeah.